Good afternoon, everyone. Today we will only have one example to look at, so let's begin. First, let's rewrite this differential equation using dy dx notation. So I'm going to replace y prime with dy dx. And while I'm at it, I'm going to factor out an x, because we really want to have x on one side of the equation and y on the other. So to get x on one side of the equation and y on the other, I'm going to multiply both sides by dx and divide both sides by 1 minus y. And now, to undo the derivative, we need to take the integral of both sides. So if you think about it, if this was just 1 over y, the answer would be natural log of y. But it's 1 minus y, so it's going to be natural log of 1 minus y. However, because of the negative sign, we'll need a negative sign in front. Remember, you can always check to see if you've done the integral correct by taking the derivative. So let's just think about this for a second. The derivative of negative natural log of 1 minus y would be 1 over 1 minus y, but then we'd have to take the derivative of what's inside, and the derivative of 1 minus y here would be a negative 1. So we've done this correctly. If you can't quite understand this, you could do a little bit of use substitution to take the integral of this side if you wished. Now I'm going to take the antiderivative of the right side of the equation, so I'll have x squared over 2, and then we have plus c. Now, you might say, oh good, we're all done. However, we need to actually rewrite this so that y is by itself. So now we need to rely on our skills from pre-calculus. To begin, I'm going to multiply both sides by negative 1. So on this side, I just have natural log of 1 minus y. And then I'll have negative x squared over 2 plus negative c. And then I'm going to remember that this is natural log, so it's base e, and so I'm going to rewrite this as an exponential function. So I'm going to have e to the negative x squared over 2 plus c is equal to 1 minus y. And we need to get y by itself, so I'm going to subtract 1 from both sides. And at this point, I know I need to multiply by negative 1, but this over here is a little bit messy. I'm going to rewrite this a moment and call this e to the c times e to the negative x squared over 2. And this is very commonly done in working with differential equations. And you might be wondering, well, why is it possible to do that? So think back to working with algebra. Let's say I had 5 to the 6 plus 3. Well, we could think of that as 5 to the 6 times 5 to the third. The bases are the same, so we add the exponent. So I'm basically doing this property in reverse. I'm changing it from 5 to the 6 times 5 to the third and rewriting that as, well, I have a sum, I'm rewriting it as a product. So that's what's going on here. This ends up being a constant. So I'm going to actually replace e to the c with c1, like we did yesterday with the example that we looked at. And then to finish, we would need to, oops, I had a negative sign that I somehow dropped there. Let me fix that. To finish this, I would need to multiply both sides by negative 1 so that y becomes positive. So I have y equals, and I'm going to write this with the 1 first, 1 minus c1 e to the negative x squared over 2. And I know that one was a little bit messy, so that might take a little bit of getting used to doing those types of problems where you have a natural log. But once we've taken the antiderivative, which we have right here, let me bring that back there. Once we take the antiderivative, we then need to write this back into exponential form so that we can solve for y. So I know that the 1 or 2 examples that you have on your homework assignment from this section might be a little bit challenging, but we'll take a look at those in class when I return.